Good afternoon, I'm Karthik. I work at Cloudera. We build this thing called Hadoop and sell it to people. How many people have used Hadoop or MapReduce or any other form of MapReduce? Right, cool. Nice. Good to see that. And so we get this question from our customers very frequently, and people in general want to know how would adding SSDs to their cluster help with their MapReduce performance. And from Cloudera's perspective, we need to know about that, so we started investigating it. My colleague Yanpei and I did a bunch of experiments, and we are here to present that to you. So what we did was we took a bunch of machines that had SSDs on them and then started running MapReduce jobs and just to see what would happen. And what we saw in a nutshell is that SSDs give up to 70% higher performance, have 2.5 times higher cost per performance. I'll talk more about cost per performance later. And when you have a hybrid cluster which has both hard disks and SSDs, the way you would want to split your SSDs is so that individual local directory, if you understand how MapReduce, the Hadoop implementation works, that directory granularity should be roughly the same bandwidth as a hard disk's bandwidth. And what we see is that there's been a lot of work on cost per capacity, and no one really talks about cost per performance when they compare hard disks with SSDs. And if you really want to use SSDs for performance, you need to be looking at that. And our experiments have primarily been twofold. One is, if you are setting up a completely new cluster, do you use hard disks or do you use SSDs? The other option is you have already some clusters running and they have hard disks on them, and then you want more performance. Should you be adding more hard disks or should you be adding more SSDs or a single SSD? And for that, we have used this hardware, which has a bunch of configurations. The base configuration is something that has 6 hard disks per machine. Each has 120 megs per second of bandwidth, so the overall sequential aggregate bandwidth is 720 in this case. Then we added 5 disks to that setup to get HDD 11. Why 5 disks is because we wanted to match the sequential bandwidth of the hard disk ensemble and the SSD. So you have the SSDs have 1300 megs, the particular SSD that we used. And so we matched it with the HDD 11 setup. And we have a hybrid setup which has 6 hard disks and 1 SSD. And the prices are on the rightmost column to just get a feel for how things are. Before we go into the actual results of what we saw, it would be nice to see, kind of expect what would happen. And so we were looking at the MapReduce data flow and what happens. In a typical MapReduce job, there's map phase and reduce phase. So you have map tasks and reduce tasks, of course. And the map tasks read data from HDFS, and the reduce tasks write data to HDFS. And HDFS block sizes are at least 64 megs. These days, people typically use 256 megs. So you're reading a chunk of, like a larger chunk of data at once. And in the middle between the map phase to the reduce phase, when you transfer the data, that part is more interesting. It's more nuanced. You have a map side sort, a copy that goes from maps to the reducers, and then a reduce side merge that merges the data, incoming data. And all this data is, of course, like more partition, more finer than the data that you read from the mappers themselves. For instance, if you have like if the ratio of input to intermediate to output is 1:1:1, the map outputs themselves are, if you have 10 reducers, each map would have only 1/10 of its output is to a reducer. And if you have like 100 mappers, then you are like already, a particular partition is 1,000th of the entire data that you have. So it's much finer data. And what we thought was, because this data is so small and SSDs are supposed to help with random IOs, shuffle would probably benefit a lot from using SSDs. And maybe the read and write would not probably, like the HDFS read and HDFS write would not probably be affected at all. So to validate this hypothesis, we looked at this workload, which is essentially we looked at as I said, input is to intermediate is to output, and we varied the ratios a little bit to see what we get. We have the TerraSort suite, if people know about it. It's just you generate a bunch of data, you sort it, and then you validate that it's actually sorted. Then you have word count, which just counts the number of word occurrences in that data. And there's shuffle, which has no input. It has no output to HDFS. It just, in the map phase, generates a bunch of data and just shuffles it across and then discards it. That's all. And these might seem very simple benchmarks, but they do capture the input-intermediate output ratios that we wanted to look into. And there are a couple other here, TeraRead and HDFS data write. They're slightly different from TeraValidate and TeraGen, but mostly similar. So what do we see here? We see these numbers. If you see, the yellow is SSDs and the blue is hard disks. And if you see, and on the y-axis you have the running time normalized to the HDD, so HDD is always 1. And the yellow bars are all lower than the blue bars, which is good, I think. Like, the only exception to this is word count, in which case the yellow bar is almost the same as the blue bar. The reason for this is word count is very much CPU intensive, so improving the I/O did not really help it. Makes sense. So it was clear to us why shuffle would do better, but we were very surprised to see that TeraGen does better. We saw that TeraValidate does even better. So we were kind of curious to see what happened. And we started collecting some collectile data. And what we saw was SSDs are actually better for sequential I/O as well. What we have here is the I/O granularity. By I/O granularity, I mean for each I/O operation, how much data do you read or write? And what we see is the amount of data read. Like, this is for HDFS read, but there's also a very similar graph for HDFS write. And what we have seen is the SSDs read or write a lot more data per operation than HDDs. And because of that, they take fewer operations, and their throughput is generally better, and they do well. And if you look at the random I/O, which is the shuffle I/O, the shuffle read sizes are, there are 2 points to see here. One is that the difference between HDDs and SSDs in terms of I/O granularity is actually smaller. But as such, the I/O granularity is significantly smaller than what you see for HDFS reads and writes, like the difference in the amount of data, total amount of data that you're actually reading or writing. And even though the difference is so small here, you still get better utilization or better throughput with SSDs because of whatever the seek overhead. SSDs don't have a seek overhead, and you see that. So based on this, would you pick SSDs or hard disks? And we thought cost is probably something that people would want to know. So we looked at how we would measure, like how would we quantify the amount of money I had to pay to get this additional performance. And we thought cost per performance is a good metric for that, and we started computing it. Disks cost less. It's only $400. They have a higher capacity. But the unit bandwidth is 120 megs. And what we have done is, in this particular graph that you see, we just took those durations, and we looked at the performance, and so if you multiply the duration with the cost, you would get cost per performance, because performance is inverse of the time taken, the make span. So when we do that, what we see is SSDs are about 2.5 times more pricey than hard disks. So if you want your MapReduce jobs to go fast, like if you really want, and if that's going to bring you 2.5 times more revenue, then probably you should spend, or some reasonable amount of revenue, then you should probably spend that extra money to get performance. But of course, there's a caveat that SSDs still have lower capacity than hard disk if you're just looking at that. And you want to keep that in mind to see if the lower capacity is going to hurt you in any way or not. The one other thing that people talk about is if you're using SSDs for shuffle data that is temporary, you probably run through your number of write cycles on the SSD faster, and you need to account for that cost as well. There is the energy efficiency cost, where like SSDs take less power to run. Also, they heat less, so in data centers, you would pay lesser cost to take care of SSDs than it is needed for hard disks. So all these things need to be taken into account when you account for this cost per performance. Right now, we only looked at what the setup cost is and what the performance is. We have a bunch of future work to do here. If you notice, we have done a single MapReduce job runs here. We didn't really go through, like we ran a MapReduce job one by one. We did not put a bunch of jobs and see what happened. So we would want to do that, use some kind of workload generator like Swim. We want to investigate other components. MapReduce is just the beginning. We want to look at HBase, Impala, Search, Spark, and Zookeeper. Some of these, like HBase and Spark, cache data, and we want to see if we can use these SSDs to extend the cache as a second layer of cache, and that would help with their performance. And so again, if you see these experiments, we were keeping the aggregate sequential bandwidth constant between the setups, and we were trying to compare them. The other thing that you can do is you can keep the cost constant and put how many ever disks you can to match an SSD's cost and see how much performance that generates for you. And I talked about all the operating expenses. We need to put those things together and explore the total cost of ownership. That's all. Thank you. In this talk, I did not go into the second part, which was looking at the hybrid where you already have hard disks and you're either adding hard disks or adding SSDs. That's all in the paper. You can take a look. Thank you very much. And given the amount of time we have, I would leave you with this slide on how the hybrid setup is much faster than hard disks. And the hybrid setup that we care about is the brown line here. And the hard disk is the sky blue. And any questions, I'll be happy to answer.
I'm sorry, I'm in post, so if you covered this and I missed it, my bad. So at this size disks, there's a lot of talk about how you want to make sure you're using GPT and 4K sector size, otherwise the drives will emulate 512 and you can lose a lot of performance like that. Did you cover that and did you do that or?
No, we actually did not change anything at all. Like we just took a regular file system on hard disk, whatever comes out of the box, and we ran on it.
For your partitioning scheme, did you use both DOS style or did you use GPT?
We just used the whatever.
Okay.
Yeah.
Thanks.
I do believe we use the 4K sector sizes. Okay. Yes.
Thanks. Please thank the speaker.
Thank you.